Okay, good morning everyone. Welcome to the fifth week of this course. Things are going to become even more interesting from this week on. We actually start working with real data and do analysis, and I guess many of you have been already waiting for this for some time. During the first weeks, we learned the basics of Python, and now we are hopefully prepared to do a bit more uh, challenging tasks. So we start working with data analysis and exploring different kinds of data. So in today's lesson, we start working with the library called pandas, and soon I will start introducing the library to you, but you have already heard the name a few times already during this course. Our learning goals for today: hopefully after this week's lesson you will be able to read and explore tabular data in Python. So you have probably worked with different kinds of data sets coming in different formats, like different kinds of spreadsheets. So we will see how to work with them in Python using pandas library. And you will also learn to do simple data analysis using pandas, data structures, and functions. And you will also be able to write data to a CSV text file by the end of this lecture. So, yeah. Yeah. Okay. Okay. So, as you probably remember, last week we published this midterm feedback. We have only 8 participants so far, which is quite a small considering how many students we have in this class. So it would be great if you can, if you haven't done it already, please fill out the feedback form for us. It will help us a lot in improving the course and see what we are doing right or what things should be still improved. Yeah, so if you do that, maybe next week we can go through some of the feedback. Yeah, so please do that if you haven't done it already. Yeah, so the library that we are going to work with today and in the remaining weeks is pandas library. The name is cute, but unfortunately it doesn't have anything to do with pandas, except if you have some data about pandas, I know the population, their distribution. Of course, you can use pandas library to study it, but otherwise, I don't see any connection. Uh, the name pandas comes from panel data analysis, something like that. So that's where the name comes from. Yeah, so it's a very popular library, originally written by Wes McKinney, and he has also written a book on this. We have put the references to the book on the course's website. So yeah, so it's a very popular library in different fields of science for data analysis, and there are a number of reasons why it is popular. Well, of course, it's a high-level library, so it is building on different kinds of libraries, and it is popular for a number of reasons. One of the reasons is that it has rather easy to use data structures. So you will see during today's lecture and later on during the coming weeks that the data structures we use in pandas are very intuitive. So they have this kind of table-like look, which makes it very easy to understand. And since it's building upon a number of other libraries, there are a lot of functionalities coming from other libraries that you can just easily use if you're using this library. For example, later on we will learn how to use how to make different kinds of plots, and pandas is using matplotlib, another library that we will be working with in coming weeks to just help us make different kinds of visualizations. So as I said, it's combining functionalities from many Python modules, and it's a nice package providing you with a lot of functionalities that you probably need for your data analysis work. Another library that Pandas is taking advantage of is NumPy, which is a very powerful module for doing different kinds of data analysis and calculation work. So many functionalities are coming from NumPy. I already mentioned matplotlib for visualization, and also pandas is using under the hood the SciPy module, which is a very popular module for doing different kinds of scientific, mathematical, engineering related calculation work. So yeah, another good thing that makes pandas library popular is that it supports many types of data that you probably will like come by. So you can use different formats for reading and writing with pandas. For example, you can easily work with CSV, JSON, HTML, SQL, and like different kinds of data that you might have access to in your work. So that's another great thing about this pandas library. So now we are going to start working with pandas library. As usual, let's go to our Noppe environment and pull the latest changes. This one. Okay, so let's get started with pandas. Just I already said a few things about pandas library. There are different. It's a good library that supports many formats, and it's built on many different libraries that provide us with different kinds of functionalities. And I already said that one of the things that makes pandas popular is the data structure it uses and the fact that it is quite intuitive. So in pandas, and this is something that is a source of confusion for many people if you don't understand it well enough at the beginning. So this is the data structure that we use in pandas. So we have data frames, or pandas data frames, and pandas series. So the main difference between the two is that, well, a data frame is a two-dimensional object. It's a data structure. So we have columns and rows. So it's very much like the tables that we are all familiar with. So it's like a spreadsheet kind of. So we have columns and rows. It's two-dimensional. Then pandas has also a second, more basic data structure, and it's called pandas series. And it is just one-dimensional. So it can be one row in your data, or it can be one column in your data. So the difference between a data frame, a pandas data frame, and a pandas series is that data frame is two-dimensional. You have rows and columns. A series is just one-dimensional, and it can be a row in your data or a column. But we are going to look at that in soon. But let's take a bit closer look at the data structures in pandas. So on the left, you can see the pandas data frame. This is just an example of a data set that we will be working on with. So let's continue. Yeah, so if you take a closer look at the data structures in a pandas data frame, well, this is what you will see in Jupyter Notebook, and the reason is that Jupyter Notebook does a bit of a styling, so things look a bit nicer. We have these different shades for different rows, and things look a bit nicer. But what we actually have outside Jupyter Notebook without all this styling is this. So this is what a data frame looks like in pandas. It's not as nice as the one you see on the left, but it's a very understandable structure. You can see you have the rows clearly defined, and you have the columns, and you see the name of the columns at the top of each column. So we have different values, as you can see in your data. So these are the data values. One thing that is a bit familiar for you already, because you have worked with Python lists during this course, is this index value. So the first column, so this is your actual data starting from year moda here in this data set. But when you create a data frame, or when you import your data into a data frame, it creates an index column for you. So it's just a unique identifier for rows. We will see how we will need this later on, basically for selecting different kinds of rows and doing different kinds of operations. So by default, when you do this, the index value is just an integer starting from 0, but we will see later on that pandas library is actually flexible with that. So the index values Like when we were working with Python lists, you saw that it's always an integer starting from 0. But when it comes to pandas library, by default, it's similar, but you have the flexibility. So we can use different data types, different values for as the index for our rows. So each row is identified by this unique index value, and the columns are identified by the unique name they have. And it can be different things, of course, depending on what they represent. Like it's a so each we have different rows in our data. That's often the case when you're working with any kind of data set, and you have different columns, and each column is storing some information. It's just one dimension of your data. So in this example, you can see here we have a column called year moda, and we're going to dig into this a bit more in a few minutes. So it's holding information about the date when the data reading was recorded. And then we have columns such as temperature and maximum and minimum temperatures, which are keeping information about temperature and the maximum and minimum temperature. So this is the data structure. So a data frame is two-dimensional, and it is made of pandas series. So if you just look at one row or one column, so each of them is a pandas series. And then working with pandas series, we have a similar structure. Again, we have index values, and the column has a label, and we have also different data formats. So in one data frame, you might have different columns, and each of the columns might come in a different format. So you might have a column that is float, one can be integer, one can be string, so there's no restrictions on that. Yeah, so this is the overall structure of data frame and data series in pandas. Is this clear, or do you have any questions so far? Yeah, so let's continue and see how this works in practice. So now we are going to work with a data set. So the data we have collected is from the Finnish Meteorological Institute. So it's from FMI, it's from 2024, so it's from this summer, last summer. And it has temperature. So we have two readings per day. So we have temperature 1. As you can see, there's a snapshot of the data here. We have temp 1, which is the temperature recording, and it's coming from Kumpula station, so right next door. We have temperature 1, which is the temperature recorded at 10 a.m. in the morning. And we have another reading from the day, which is named temp 2, which is a temperature reading from 4 p.m. So that's what we have. Also for each day, we have a minimum, maximum temperature in separate columns. And this is the data structure that we were working with. So I would like to note that next week we are going to work with the similar data, actually the same data, but in its original format. This is a bit edited for this course. So the data is real, it's coming from FMI, but we have changed the formatting a bit to show you some tricks how to work with these CSV text files. But next week we will work with the original format and show you how you can get the data and start working with it. So yeah, so if you're curious to see the data, yeah, so the data is now missing, but Dave is working on it. In the meantime, I can show you the data structure. So it's a TXT file. So once it's there, we can open it and take a look. But this is how it looks like. So in the first few lines of the data, we have metadata. And probably you know what is metadata. So metadata is data about data. It gives you some information like about the data. So in our case, it's just telling you that, okay, the file format is CSV. These are the columns. These are what the columns mean. So as I said, temp 1 is collected at 10 a.m. and temp 2 is collected at 4 p.m. and so on. It also tells you about the period from which the data was collected. In our case, it's from summer, starting from 1st of June to the end of August 2024. And we have also the data source. and a bit of information about data processing. So as I said, for this lecture, for this week, we processed the data a bit and changed the format. So we have added a bit of information in the metadata, what we have done here. And of course, it's very common in metadata, there is information about the date on which the data was prepared, and also the person who has taken care of the, who has prepared the data. In this case, it was me who prepared the data. So this is what the data looks like. Yeah. So now if you pull the changes again, the data should be there. So let's do this now. Okay. Okay. So now you see a new directory is added, data. So if you just open the directory and open the file that we have there, so this is what I was talking about. So we have our data starting from row 9, and then we have a bunch of other lines information like metadata. It's not part of our data, but it's still useful information about the data. So this is the data set that we are going to work with. Yeah, so let's get it started and work with pandas. We saw last week how we can import different libraries. In this case, we are going to work with pandas. So I'm going to import the library, pandas, like this. And we saw last week that you can give a short name to libraries. When working with pandas library, it is very common to use the short name PD, because whenever you're accessing a function or something from the library, you have to type in the name. So PD is a little bit shorter than pandas. So I'm going to import the library like this. The next thing I'm going to do is to access the data. So I'm going to read the data. So I'm going to read the data and store it in a variable called conveniently data. So this is how you do it. So under pandas, the library we just imported, there is a function called read underscore CSV. As you can guess from the name, it's a function that allows you to import data in CSV format using pandas. There are a number of rather similar functions allowing you to import different data types using pandas. For example, as I said, pandas does a good job importing, like being able to read different data formats. For example, if you're working with pickle format, then there's a function called read underscore pickle that allows you to import this kind of data. And you can read more about this in documentation. But now we are working with CSV, so this is the function we are going to use. And next, you have to provide the path to your data. In our case, the data is stored under data directory. So I'm just giving relative paths to my data. And the name of the file, you can just copy it from the name of the file. I'm going to just type it in. So it is called Kumpula-summer-2024. And the extension of the file is txt. It's a text file. So if I look at the data again, well, the extension of the file is txt, but the format of the data actually is CSV, so it's comma separated data. You can see different values in your data are separated with comma. So that's why it's called CSV dataset. So yeah, so the columns, the values between columns are separated using commas. That's why we are using this function read CSV. So let's close the bracket and run this. If you don't have any typo, you shouldn't get any error. The data should be loaded, and now it's under data variable. So now that we read the data, we want to check the contents of our dataset. So one of the nice ways of checking what you have just done is using a function called using this head function. So if you just put the name of your data, well, the variable in which we have stored the data, and .head method, it will print out the first 5 rows of your data. In this case, it doesn't look right. So you can see that we have a bunch of random information and a lot of missing values. And the reason for that is that we looked at the data already. We had a number of lines which were metadata. So the data didn't actually start on the first line of the txt file. But pandas doesn't automatically know that. So what it's doing is just starting to read the data from the very first line. One thing you can do with this head function is to put a number. So by default, if you don't put anything, head is going to just print out the first 5 rows in your data. But of course, if you put a value, it will, like in our case now I put a 10, so it's printing the first 10 rows of data for me. So I can see that, okay, it's reading the metadata and just it's confused, like we have a lot of missing values and things don't work, and then at some point the real data starts. So we are going to take care of that, but before that, let's take a look at another useful function, and it is the tail. So with head, you get the first 5 rows of your data. It's a good way of taking a quick look at how your data looks, and if you have just imported your data, it gives you an idea whether it's been loaded correctly or not. Tail gives you the tail of the data, so it shows you the last 5 rows. So if you just run this, you can see, you can guess from the index values, these are the last 5 rows of the data. Similar to the head function, if you provide a value here, for example, if I put 10, it will give me the last 10 rows. So the default value, if you don't provide anything, is 5. If you put something there, of course, it will give you that many rows. So we already know that the source of the problem why things don't look right at the beginning when we import the data is that we had some metadata at the beginning, and we have to tell pandas, we have to now try to import the data set again, but this time we are going to tell pandas that, okay, you should skip those rows. So if you look at the data, you can see we have 8 lines of information that we do not want to import. So if we want to import this correctly, we should ask pandas to start from line 9. And luckily this is fairly easy to do using pandas library. So I'm going to import my data again and just overwrite it here. So I will use again the name data for storing my data, the data I'm just going to import. I will use the same function for importing, read underscore CSV. Again, I'm going to give the path to the data. So it was under data, and the name of the file was kumpula-summer-2024. And don't forget to put the extension, which is .txt. So now I'm going to pass in one parameter. So you remember last week we were talking about functions, and you saw that some of, well, this is an example of a function where you have a number of parameters which are optional. So you have one parameter that you have to provide, that's the path to your file. Of course, pandas needs to know that, but there are a number of other parameters that are optional. So if you provide them, if you need them, it will be taken into account. If you don't, then it just goes with the default values. So in this case, one of these optional values that you can provide to this function is a parameter called skip rows. As you can guess from the name, it just tells pandas that, okay, skip this number of rows, and you can provide an integer as the input. So as we saw from the data, the first 8 rows were metadata, so I'm going to skip the first 8 rows, starting to read the data from the 9th line in my txt file. So let's run this, and this should now import our data. Let's again use this data.head. This is something we are going to use many times. It's useful when working with pandas. So now you see that it looks better, but it looks good. So the data is loaded properly because we skipped the metadata lines at the beginning, and it's starting from the beginning of the actual data. We can see we have the temperature recordings from 1st of June 2024. So let's also look at the tail of our data. It also looks good there. As you can see, we have temperature recordings until end of August 2024. So the last reading is from 31st of August this year. So you see that we have 92 rows of data. The index value, the last one is 91. And the reason is that the index value is starting from 0, similar to what we saw when working with Python lists. But we have 92 rows of data. And we have column names, which are meaningful, so we can guess what they mean. Yeah, so by default, the column, the index value is integers, I said before, but later on we will see that it can store also other kind of data formats as well. Okay, so let's take a minute or two and try to answer this question 3.1. So how would you read the file, the same file that we just imported once again? But this time we want to select only two columns. So we want to only use year moda and temp1 when importing the data. So we don't want to overwrite what we imported earlier, so let's just store it under a new variable name. Let's call it temp underscore data. So just spend a minute or two, try to see if you can do this on your own, and then we will do it together. There is a parameter you can pass in. You can also check the documentation, but of course we go through it together. Use call, so you can provide a list of the column names that you want to be imported. So this is another optional parameter that you can pass into the read CSV function in pandas. So use this use calls and provide a list of the name of the columns that you want to import here. So let's do this together and see how it works. So I'm going to make a new variable, call it temp data. And again, I'm going to use this pd.readCSV function. So again, I'm going to provide the path to our data. It was stored under data directory. And the name of the file was kumpula-summer-2024. Again, I'm going to skip the rows where we have the metadata. So I set the skip rows to 8. So this is what we are doing now differently. So as I said, we can pass in one parameter here to the function called use calls. So it's use columns. And then I'm going to provide a list of the columns that I want to use while importing the data. And we already know how we can make a Python list. So the one column that I wanted to import is this year moda. So I'm just going to type it in. There's a second column I also want to include while importing the data, and that's temp1. So let's also add this temp dot head at the end, so to see if we did this correctly. Yeah, it's use calls. I forgot to put the S, so let's correct it. Yeah, so now we imported the data again, and this time we only have two columns. So this is also a useful thing. Yeah. Yeah, good point. It all gets messy, so it doesn't identify the columns correctly, and if it doesn't identify the columns correctly, then addressing them, that doesn't make much difference. Yeah, so this is a useful thing we can do with pandas. Very often when you get your data from some source, there are many columns, not all of which you may not require for your work. So it's handy to just use columns that are useful to you so it doesn't get so messy. So yeah, so now we learned how to read data with pandas. Now, similarly, we do something similar but with different purpose. Now we want to write the data, so the functions are quite similar, but let's see how that works. So writing data to, so this is a also important part of your process. Usually when you import your data, you do some kind of analysis, you want to do some kind of calculation at the end. Very often you want to export your data. So this is how we do it. So one thing you have to do is to define a name or a path to the file. So here I'm just going to save it in the root. If you want to save it again in the folder, of course you can put data slash, then it will be saved in the data. So you provide the path to the file where you want to save it. In this case, I've saved it under output file path. The next thing you need to do is just use a function called toCSV. So data is the name of the data frame which we want to export, and this is the function that we are going to use. So to_CSV, as you can guess from the name, it's going to export your data to CSV format. You need to provide the path. You either type it right here. In our case, we have stored it already in a variable, so I'm just going to put the name of the variable, which is output_fp. And two, yeah, sorry, I have a typo. Yeah, so it's toCSV. Thank you. Then another thing you can specify here is the separator. This is something that you could also do when importing the data. So there is this optional parameter. In our case, it was a classic CSV data file, which was separated with comma, but you might get your hands on data sets that use other signs as separators. So it might be like semicolons or spaces or something. So with this separator parameter, you can specify which separator is used. In our case now, we want to export our data in a classic way and use the comma as the separator. So if you just run this cell, you will see that a new file is created for you. You can just open it and check. There's also a screenshot here. So it just created you a CSV file that has your data in it. So one thing that you notice here is that, of course, it was a data frame that we exported into a CSV, and we already saw that CSV data frames have a first column index value. So you can see when you were exporting this data set, this index value was also written to the output file. So let's see how we can remove that. Probably this is something you don't need in your data. Another thing we can fix here is the number of, for example, decimals. So here we have 1 digit of decimal. If you want to modify that, we can pass in a parameter and take care of that. So if you don't want the index column to be written out to the output file, you can set a parameter, pass in a parameter called index and set it to false. So it's going to tell pandas that I don't want that index column to be written to the output. And if you want to use a floating format, for example, if you want to specify how many digits of decimals you want, then you can just specify. In this case, if you set float format to 0, it's not going to include any decimals, or if you put it to 2f, then you get 2 decimals. This is something we saw earlier when working with f strings. So let's quickly try this out. So I'm going to, the file path for the second file is written out here. So I won't type it, you don't need to type it. Then I'm going to export my data again using the same function, so CSV. Then you provide the path to the data, which is in our case stored in a variable already. So again, I'm setting the separator to same as it was last time. So I'm going to use commas. Feel free to try other things. Then I'm going to set the index value to false, so it won't be written to my output file. And then I'm specifying a float format. And I want it to be without decimals, so I'm just going to put %.0f. Remember to close the bracket. So now that you run this, you see you have another file that appeared in your directory on the left. Yeah, so there's you can open the file and check what the contents, but there's also a screenshot here. You can see that, okay, now the index value doesn't appear in the output anymore. And also that we got rid of the decimal. So depending on what you need, you can do these things. Yeah. If you specify the name, it doesn't matter at all. So if you say that, okay, index equals false, it doesn't matter where you put it because you're saying it's index. You're putting the name of the parameter. But in other functions, like if you're not naming the input name, the parameter, then it has to be in order. Yeah, but when you have the name of the parameter, the order doesn't matter. But good question. Okay, so now we learned how to read CSV files using pandas. We also learned how to export it, write it into a CSV file. Now let's explore some of the properties of data frames and see what things we can do with our data frames, what kind of information can we get. So one useful thing that we often start our work by doing, doing this is to check the length of the data. So you very often want to know how many rows of data you have. So one common way of doing that is using a function called len, which is short for length. So you can just pass in the name of the variable where you have stored your data. It's going to give you the number of rows. So in our case, we have 92 rows of data, which makes sense. This is from summer. So 1st of June, end of August, we have 92 days and therefore 92 rows of data. Another thing we can use, another useful attribute of data frame is .shape. So if you just put the name of the data variable and then shape, this gives you the number of rows, 92, which we already saw, but also the number of columns you have in your data. So it gives you the number of rows and columns in your data. Let's also check the column names. Of course, we saw already that, for example, you can see the column names when you do .head or .tail, but sometimes it's useful to just print out the name of the columns if you want to handle them programmatically or do something. So one way of doing this is using data.columns.values. And it's going to return you a NumPy array with a list containing where you have a list of the columns that you have in your data. So they appear here. If you want to get some quick information about the index in your data, you can use data.index. So it gives you some quick information about how the index is structured in your data. So we have the index, in our case, is integers starting from 0 to 92, and we have a steps of 1. As I said, pandas is flexible with index, so this information can be useful. Very often it's useful to just take a quick look at what kind of data types you have in your columns, and you can easily do that in pandas using .dtypes. So data.dtypes is going to give you a list of your columns and what data format they have. So we can see the year mode here is loaded as integer, it's identified as integer, and then you have those other columns, maximum, minimum, the temperature columns, which are in float. So you also have decimals there. Okay, now I'll give you 1 minute to try something. So do you have any idea how you can get the number of columns in your data? This is a tip, you can use that len function that we saw a bit earlier. Yeah, so we can easily get the number of the columns just using len. It gives you we had a list of column names, and then with len we just count the number of items in it. So it gives you 5 as the output. So we have 5 columns in our data. Okay, so next we are going to learn how we can select different columns in our data. So one thing we did at the beginning was that, okay, when you're importing the data, you can already select what columns you want to use, include in your work when you're importing the data. So we use the use calls parameter, but very often you have imported the full data or bigger data and you want to select smaller data with fewer number of columns. So you can easily do that. So let's make a selection from our data. And I'm going to name it selection. And the way to do this is that you can provide, so if you want to make a selection of your data and store fewer number of columns, you have to provide the name of the column. So if you have more than one column, this takes only one input. So if you want to provide longer, like a number of columns, then you have to provide a list. So let's type this in and I will explain this a bit more. So year mode is the column I want to include, and also the other one is max. So remember to close the bracket. So this is a common source of syntax error if you forget to put these double brackets. As I said, here you can just provide one input. So in case it is just one, if you want to just include year mode, then you would have just one bracket, year mode inside, and that's it. But if you want to include more than one, in this case we are including 2 columns, then it expects you to provide a list. So the first bracket, the inner bracket you see here, is a list of the column names, and then the outer bracket is just a pandas thing. So let's see if this worked. To see if this works, I'm also adding this dot head to the end. Yeah, so now we made a selection of our data. We stored it under a new variable called selection, and this only includes 2 of the columns from our original data, year, mode, and max. So let's just quickly check the type of output. So what is selection now? So you can see when you make a selection of your data, if it is again 2-dimensional, in this case it's 2-dimensional, we have rows and we have 2 columns, the output is again a data frame. So this is same format as same structure as we had in our original data. Let's check the shape of our data frame using selection.shape. We saw this earlier, so it gives me the number of rows and columns. So again, we have 92 rows. We didn't change anything there. We just have fewer columns. Now we have only 2 columns. So if you want to access quickly one column in your data, you can just do it like this. So for example, I want to try the dot head. I want to see the first top 5 values, the first 5 values of my max column. I can just do it like this. So here note that we have only one bracket, and the reason is that we are only passing in one column name. If we had more column names, then it had to be a list, then you would see two brackets here. So if you just run this, you will see it gives you some, well, you see the first top 5 values, the first 5 values of max column in your data frame, and you can see it's a float. So similarly, you can do other things. So if you want to try a type specifically for this column, again, you can do a similar thing. So now you see that it suddenly became a pandas series, and the reason is that we only have one column here, so it's no longer two-dimensional. So now that we have only one column, it is pandas series because it's one-dimensional. So this is one maybe better way of accessing columns. There is another way of accessing contents of a column, and that is by using dots. So instead of putting a bracket and then putting the list of the name of the column, you can just directly say data.max. So we could have done the same thing here like this. It will give you the same output. You can do the same thing when trying here. So instead of data bracket max, you could just put data.max. So this works very well and it's easy and very intuitive, but there is one problem with that. Pandas is flexible with how you have the name of the column. So in the name of columns, you might have spaces, you might have different signs. So if you're using this dot method and you have a space in the name of the column, then you will get a syntax error. So it doesn't work. So with this bracket method, you can just have whatever name. If it has any signs in between, any number of spaces, you don't run into any issue. So this is a more universal method, regardless of how the columns are named. But if you use this dot method to access the contents of a column, you have to be careful. If you have a space there, if it was like max space temperature, this wouldn't have worked because it just gets confused. So yeah, so this is also useful, but you just have to be careful with it, not to run into any issues. Sometimes it's useful to extract the unique values that you have in your column. We can do that easily using the .unique attribute. So let's just try it for the same column. So I want to get all the unique values in the column max. So this gives me you can see you have a list of all the unique values. So in your data, some value might have repeated a few times, but here you can easily get the unique values that appear in your data. So this gives you a list of the unique values. If you want to get the count, so you want to know how many unique values you have in your data, you can just use n unique, and it will give you the number of unique values. So let's just quickly write a print statement. So I'm going to just yeah, so there where so I'm going to write just a print a string, and there I'm going to put the number of unique values we had in our column. So remember, we can use n unique to get the number of unique values. And then I just continue with my text. You can write what you want. So there were this number of days with unique maximum temp in summer of 2024. Yeah, so there were 56 days with unique maximum temperatures in summer of 2024. So just easily you can get the count of unique values in your data frame, or in this case, you're just accessing one column in our data frame. Another useful thing you can do rather easily using pandas data, pandas library, is getting the descriptive statistics fairly easily for different columns in your data. So this is also another useful thing when you're analyzing your data, especially at earlier stages. You want to get an understanding of what you have in your data set. So again, I'm going to work with this max column. And this time I'm going to get the mean, the average value of my column. So if I just run this, it gives me a float like 22.04 and with many decimals. So very easily you can calculate the average value of a column. Similarly, if you want to do it for all the columns at the same time, then you can just put data.mean without specifying a specific column. So this time you get the average value for all the columns. So for year, moda, and maximum, minimum temperatures. So for each of the columns, the average value is calculated. So, and if you want the number of default descriptive statistics calculated for your data frame, you can just use data.describe. And it gives you some basic descriptive statistics which can be useful for understanding your data. So you can see the count, the average value, standard deviation, like the quantiles, minimum, maximum values. So yeah, and you see it for all the columns in your data. Okay, so now we just we calculated this descriptive statistics for all the columns, but of course for the year moda, it's integer, it just calculates it, but it doesn't make anything. What does it mean? Like the average of dates. So it doesn't make sense. So let's take a minute or two and try to do this again, but this time we exclude year moda from our calculation. So we just want to calculate this descriptive statistics for these 4 columns without year moda. So let's spend a minute or two and do this. So again, note the double brackets because we are going to provide a list of columns because we have more than one column we want to include here. So one is temp 1. The second one I want to include here is temp 2. And then we have the max column and then mean. Remember to close the brackets and then dot describe. So now you can see that we redid the descriptive statistics calculation, but this time we excluded year moda column because it didn't make sense to be included, and we did the thing again. So yeah. So it is also possible to get other data frame specific information such as index, columns, and data types, null values, and memory usage by calling .info. Let's quickly see how that works. So if you put the name of the data frame and then info, you get a bunch of information. So this is also a useful way of just getting a quick look at your data and your data frame to see what you have. So here you can see the count of the non-null values. So when there's a missing data, well, it's a null value. So you can see that, for example, year moda has 92 non-null values. It means that you don't have any missing data in that column. But for instance, for the max column, you have 82, which means that you have 10 missing values. We will see later how to handle those missing values. But yeah, this gives you an understanding of what you have in your data. And of course, you see the data types and other information. So you also see the memory usage. So how much memory is consumed, like how much memory does this data frame take from you? In this case, it's quite a small, 3.7 kilobytes. Yeah, so here we have one optional part, and that is how to construct pandas like a bit more manually. This can be sometimes useful, but very often we get our, when it comes to analysis, we more often get our data in a structured format from somewhere. So you have a spreadsheet, a CSV file or something, then you just work with it. But sometimes it's useful, depending on what you're doing, to construct your own data frame, and it is fairly easy. So at your own time, just go through this optional part and see how you can just use Python lists to create pandas series or pandas data frames, and that can be sometimes useful. Yeah, so are there any questions? So in this first part, we went through the basics of pandas, just how to read and write data, how to explore it a bit. In the second part, which might take a bit more time, then we will go get a bit deeper into like data processing and a bit of analysis. So yeah, so maybe it's a good time to take a short break, maybe 10 minutes, and then we will come back and continue with pandas library. Yeah, so let's be back at 10:30.